Hi everyone, in today's video we will be making a obstacle detection using ultrasonic sensor. This is the sensor which we will be using. The components required are NodeMCU, ultrasonic sensor, buck converter, LEDs, buzzer, resistors, relay, and this relay is a 5-volt relay, lithium ion batteries or shell, wheel, breadboard, data cable, jumper cables, 12-volt DC motor. This is a high torque DC motor. You can use a 5-volt DC motor or this one. And on 3S battery holder which is connected in series. This video is going to be in part 1 and part 2. In part 1 we will be using relay module. As per in the part 2 we will be using H-bridge driver. This is the driver which we will be using to control the 12-volt DC motor instead of relay. Okay. As for the software, we will be using Arduino IDE. This is the IDE where we will be writing our code and uploading it to the NodeMCU. So let's begin. So this is the code which we will be using. As you can see, first of all we need to define all the pins which we will be using, in which mostly we are using all the digital pins, in which D5 and D6 are for the echo and the trigger pin, and 2 pins for the LEDs, 1 for the buzzer and 1 for the relay. As you can see, in which the echo pin is in an input mode and rest of them are in the output mode. And we need to specify, this is to specify that the relay which we are using is a low active relay, and we are using 9600 bond width to monitor our distance in the serial monitor. And the concept that we are using is, if object is detected within 10 centimeters, the red LED will be on, buzzer will be on, and relay pin will be high, and the white LED will be off. Otherwise, the red LED will be off, white LED will be on, buzzer will be off, and relay pin will be low. And we added a delay, small delay, which is 500 milliseconds. So the hardware connections are as follows. So take the breadboard, this is the breadboard, and take the NodeMCU and connect and place it on the breadboard. Now take the 2 resistors. These are 330 ohms resistor, in which we are going to connect both the resistors to D1 and D2, since we placed red LED to D1 and white LED at D2. So we need to connect D1 and here, and second is the D2 pin. Take the D2 and connect it to the okay, as you can see we have connected in this way. So take the red LED and you need to be sure that the longer is the positive one and shorter is the negative. So positive to the resistor side, negative to the ground. Same to the white LED. Now take the buzzer, in which the buzzer also has 2 pins. One is a longer pin, one is a shorter pin. Longer is the positive, the shorter is the negative. So connect the positive to the D4 and take a male-to-male cable and connect negative to the negative. Take another black cable, male to male, and take common ground from the NodeMCU and give a common ground. Now take another red cable, male to male, and make another 3 volt common supply. As you can see, I have connected it. Now take your ultrasonic sensor, take male to female jumper cable. Here we need total 4 jumper cables, as you can see. So as you can see, the ultrasonic sensor has total 4 pins, and it's been labeled on the sensor only. From the left, it's VCC. The second to the VCC is trigger. Next is the FO pin and the ground. So here I am going to connect the yellow cable to the VCC pin. Orange to the echo pin, red to the orange to the trigger pin, red to the echo pin, and brown to the ground pin. Now connect the VCC of the ultrasonic sensor to the VCC of the 3 volt supply to the board, and ground to ground, and echo pin to the D6, and trigger pin to the D5 as per the code. As per the code, we have connected this many things. Now we need to take the relay. As you can see, in relay also we have 2 models. One is active high and active low relay models. Since I am using a active low relay model, to configure whether it's active high or active low, we need to take 3 jumper cables. So here we are using 2 model relay, in which I am going to use the first relay, IN1 relay. So to configure which relay we are using, as you can see on the pins, we can see that there is IN1 and IN2, and this side you can see there is a numbering, the 2 NO2 and NO1. So means this is the first relay and this is the second relay. So we will be using this relay. So connect these 3 pins in such a way that here I am using white for the IN1, the grey color for the VCC or the ground, and orange to the VCC. And this relay operates at 5 volt. So we need 5 volt supply. For that I am using lithium ion batteries. I am going to place this lithium ion battery. Make sure when you are placing the lithium ion battery cells, make sure that since this also provides a sign of plus and minus, and in the case which holds the cell also gives the plus and minus. So make sure we are placing the plus to plus and minus to minus. Otherwise, you can see that at the minus side there are springs. So which indicates that at the spring side you need to connect the negative of the battery or the shell. So, and these are connected in a series manner. Otherwise, if you mismatch any polarity, the cells might get short. As you can see, I have placed all the cells, and now let's check the voltage, how much voltage it's providing. So take the multimeter and place it in the 12 volt DC. Take the probes and check the voltage, how much voltage it's been producing. As you can see, it's providing 8.85 volts, which is sufficient for me. Now take the buck converter and take a breadboard and place it on it. Here I am going to take two jumper cables, and at one side I will be removing the female pin or the male pin to get exposed wire, and connect it to the battery in such a way that I am going to connect the purple color wire to the positive and green color to the negative. While you are taking this buck converter, you need to check carefully which is the output pin and which is the input pin. When you rotate it, or like when you flip the node, this buck converter, you can see there are some printouts written on it. One is in plus, in minus, out plus, out minus. Means here we will input the signal or the voltage. From here we will be taking the output, and make sure that we do not connect in a reverse manner. Like if you plus to minus, minus to, since it doesn't have any reverse polarity protection, and this might get burned if you are going to connect in a reverse manner. Now take this and make sure since I'm inputting the voltage from signal, so I will be connecting this side and this will be my output side, since it's the output and output. So place the buck converter on it and connect plus to plus and minus to minus. Before connecting, cross check whether you are connecting to the same polarity or not, and the same and to the side of the input or output. As you can see, the LED is glowing. The LED is optional one. In some of the buck converters, the LED is not present. In this model, it is there. And now take your this relay module and connect the positive to the positive, negative to the negative of the output of the buck converter. Before connecting, check how much voltage it's been producing. Now again take the multimeter and check how much voltage it's producing. Okay, and place the positive of the probe to the positive output and negative to the negative. As you can see, it's producing 5 volts. So before it used to produce 17 volts or like more than this, we need to calibrate and set it to the desired value. So to set this value of the voltage as per our desired value, we need to see that on the buck converter there is a potentiometer. This is the potentiometer, and on that there is a knob. If you rotate it in my left side, it's going to be in a clockwise direction. It's going to increase the voltage. Otherwise, it's going to decrease the voltage in the anti-clockwise direction. I will show you how to do it. So take the multimeter. This positive to the positive and negative to the negative. And rotate the knob. As you can see, if I rotate the knob, the voltage is increasing. If I rotate it in anti-clockwise direction, it is decreasing. Since I need only 5 volts, I will place it at 5 volts and leave it. Now take the relay module and connect this VCC ground to ground. VCC to the VCC, ground to ground. And as you can see, this is the IN1, in which we are going to connect this. I am going to short this to the ground. Okay. As you can see, this is also the ground pin. Clearly. As you can see, the exposed pin that is on, this is a ground pin at this side. I am going to short this one to the ground. As you can see, when I short it to the ground, the IN1, it starts to glow. It means this relay model is a active low. It means at low signal it's going to be active. If we to have active high, when you need to do the same thing, but you need to connect the short this IN1 to the VCC pin. As you can see, this is the VCC pin, and you can see there is some particular short amount of metal is being exposed, and you can short it. If there is no turning or any type of action happening, it means this is active low. If you connect it to the, like if you short it to the VCC file and there is some like switching effect like similar to this one, like this sound, then it means it's active high, and it needs a active, means it needs a high signal to turn on. So now connect the IN1 of the relay module to the digital pin D4. You can see this is the digital pin D4, to which I am going to connect the relay module. And take another jumper cable. Prefer the male to female. Connect the ground of the relay module to the ground of the NodeMCU. As you can see, LED has been blinking, which means it's in a proper working condition. Now take your 12-volt DC motor. As you can see, at the end side of this pin, there are no probes, so I will be connecting extra probes. As you can see, I have connected the probes to the DC motor. Now take the positive pin and connect it to the negative side of the battery. As you can see, I have already connected to the this one, this buck converter. So I am going to take a male to male converter, male to male pin, this one, and take the negative from this one and place it here to get a common negative, and take a common positive here and place it here to get a common positive. As you can see, and connect my positive to the negative side of the battery, and positive side of the battery to the positive side to the relay module. As you can see, I have got one positive from the battery and negative from this DC motor. And now connect this in such a way that on the relay module you can find there are two types of switches. One is NO switch, NC switch. NO means normally open, NC means normally closed. Means from internally, NC means normally closed. So means if you are going to connect directly here, the motor will run directly. Let me show it to you. If I place this between the normally closed and normally open, as you can see, when I place it on the normally closed, the motor is rotating. and when if I place this between the normally open, there is no turning off motor, which means the circuit is not closed from, and which means the circuit is internally not closed. So now take a screwdrivers and take the positive supply of the battery to the COM of the relay module. As you can see, this is the COM to which I am going to connect it. And add this screw. For now, I will be leaving this. For now, I will be not connecting the negative of the motor to the relay module. Why? Because if I connect it, it's going to starts to rotate. You can see. Means if I am going to place it normally open, so it's going to be normally closed. It's going to be rotating. So I will not connect it. I will first upload the code, and after that I will be connecting this to the relay module. So now take the data cable and upload the code to the NodeMCU. Okay. So as you can see, if I place my hand in front of it, and you can see the distance is like around 2 cm up to 10 cm, like up to 10 cm, it's not able to. As you can see, okay. Now I will connect the ground pin of the motor to the normally open of the relay module. And let's check. Sorry. Not to the normally closed, to the sorry, to the normally open. As you can see, if I connect it, let's first connect our wheel to it so that we can see when the motor is stopping or not. As you can see, I placed the wheel to the shaft of the motor, and let's connect it to the normally. Okay. That's normal. And as you can see, the motor is rotating, and any object is coming within the range of 10 cm. As you can see, it's still not in 10 cm. The motor stops to rotate, and the buzzer is on, and the red LED starts to glow. And if I remove the hand, the motor starts to rotate, and the white LED is on, and the buzzer is off. So now let's start talk about the troubleshooting. The main issue that I faced was identifying the relay, which is active low or active high pin. Okay. So I already explained how to identify active low relay and active high relay. Okay, and make sure that if you are connecting the relay to an external 5V supply. Why? Because you can't take a 5V supply from the NodeMCU, since it's only supplies up to 3.3V, and also it required a trigger signal to trigger this NodeMCU, relay module. Otherwise, and as you can see, the LED is glowing here, if you connect it to the 3 volt supply, the LED, the brightness of the LED, the sharpness, how it's glowing right now, the when you connect it to the 3 volt, it won't be glowing in such a way, which means that this required around 5 volts to operate. Okay? And you also need to be careful with the buck converter while using, and you need to make sure that you are not connecting the wires in a reverse polarity, otherwise the model might get short circuited and it might get burned. And you need to also check the voltage before connecting your relay module to the output side of the buck converter. And make sure when you are connecting your power, the supply from the relay module, either it might be a negative supply or the positive supply, whichever you want to take, you can take it. Here I took the positive supply. Make sure you connect it to the COM of the relay module, and the pin from the motor will be connected to the either at the normally closed or normally open. And that's it for today's video. Thank you.